Okay, so for this first part of the activity, this is setting up the experiment. This screen is telling you about your objective. Um, and I'll go ahead and read that out loud. In this activity, we will work as a group to design an investigation about potential energy using the skate park simulation. Objective. By the end of the lesson, I will be able to explain how mass, gravity, and height affect an object's potential energy using a mathematical model. So in this screen, I'm asking you to make a wild guess hypothesis. Given this question, how much potential energy do you expect that this skater has? And so you'll go ahead and write that in here. You can express your answer in joules. This is the unit that we use to measure energy. And I would like for you to please respond about how confident you are and why. Give me a little bit of insight into how your brain is working through this problem to make a wild guess. It might truly be a wild guess for you, or it might be something that you feel like you have some reasoning behind how you're coming up with this number. Now, I hopefully we will have a good mix of folks who are doing mass, height, and gravity within this group. I'm going to let you go ahead and decide what it is that you want to change. So if you are selecting mass, you will be changing the person's mass on the skateboard and looking at how that affects the potential energy that they have. If you change the height, you're going to be changing where you place that person on the ramp and then looking at how much potential energy that they have at those different heights. If you choose gravity, you're going to be able to change the amount of gravity to put it into, let's say, gravity from Earth or Jupiter, or you can actually choose different amounts, or you can select real planets. Now I want you to write your research question. We have had a lot of practice with this. I'm looking for it to be in this cause and effect language. So go ahead and plug that in. Do remember that a question ends with a question mark. So I want that proper grammar as well. So capital letters and question mark on there. Now for the hypothesis, we do have a little bit of practice with this. I guess I already had gone through and done some of that. So let me go ahead and a little racing. Okay, so your screen looks like this. What I'm looking for you to do is to go ahead and I want you to either underline like I did before or circle um, the uh, the independent variable that you selected on that previous slide. And I want you to draw what you expect that your data is going to look like. Now, notice there aren't any numbers on here, so I'm not looking for you to be trying to give me precise numbers. I'm looking for a shape of the graph. What do you think that shape of the graph would look like? And in this section right here, I want you to put what you had there into words. Now, just so you know, you can do something like select Control C, Control V to get that sentence frame into your document, and then go ahead and, you know, put in your independent and dependent variable. Um, if you know some of these things for what it will look like, I'd be very interested if you can express verbally the shape of the graph, because that will start to get us into this pattern recognition. But generally, I'm looking for how do you think that the cause and effect relationship will look? Um, and there were a number of you who didn't put in a because statement of explaining why you think that. I really want to make sure that I get the chance to see why do you expect to see this kind of relationship? What's your understanding, your scientific understanding going into this? And think back to some of the previous activities we've done. We have experienced this simulation before. We've done the pendulum lab. So this idea of um, how these objects are moving back and forth is not a totally foreign concept. So you have some background knowledge to be pulling from. Um, and then you also have your own personal experience of understanding some of these things. So putting in some of those real life experiences will help to ground this and make it scientifically a stronger argument. Okay. So at this point, if you're working in a group, you've got a techie, and that techie is going to open the simulation on their computer and share the screen. So you can click on this link. And I want to make sure that you're going into the measure. You need to be in this one right here so that you will be able to actually take this data. So you're going to need this little doohickey here, which will measure the potential energy, all these different energy types at any particular spot on this ramp. All right, there's a lot of words on here, so I do want you to read through this part slowly. In this section, I'm describing what a controlled variable is, and we have discussed this in class. In very brief, the controlled variable is what stays the same. I want you to take some time to read through this slowly. Maybe it might take a couple of times of reading it, particularly if you are working independently. Go ahead and kind of what I like to call like whisper read to yourself, hearing it out loud and seeing it. That can be a really helpful way to understand material. This second part is about your instructions of what I want you to do. So I'm asking you to present what your controlled variables will be. Your controlled variables are going to be everything in the simulation except for your dependent variable and your independent variable. So you were given these three choices of independent variables: mass, height, and gravity. Let's say that you were like me and you selected gravity as your independent variable. Well, then you need to make sure that you're keeping mass and height the same, so that you're always checking the potential energy at the same height, and you don't want to be changing that person's mass because that can affect your results as well. So what I would do then is go ahead and put mass and height into this data table. Now, this is only true because I chose gravity. If you chose something different, you need to make sure you have gravity in this data table as a controlled variable, something you're going to be keeping the same. Second part, in the blank space on the right side of the table, put the values we will keep the same for these two controlled variables. Please find and record the default values given in the simulation. Default means like what it's set at when we start. It will help us compare results as a class. When we come back as a whole class after spring break, we're going to be looking at each other's graphs, and it'll be really great if everybody who was doing height or gravity had the same mass, so that we can compare that to what the folks who did mass, what that looks like. So these two values are given. I don't want you to change the friction. I want you to keep the friction at 0. I know that we're simplifying the world here. The track shape, I want you to keep it in this U shape here. So we've got friction to none. The track shape is at this U shape. The mass, and again, this is if you are not changing mass, well, the mass default is mass 60 kilograms right here. Okay, so 60 kilograms. I'm going to go ahead and put in that kg for kilograms. And then height is given over here. If you're not changing the height as your independent variable, use 5 meters as the value. 5 meters. So lucky folks who are doing gravity, you've got your answer right here. If you chose to change something else, go ahead and look at the simulation. Try to figure out what you're going to put in for gravity. And note, I don't want you to just put Earth. There's a number there. So there you go. So this will carry you through for the setting up the experiment. In the next video, I'm going to show you how to collect data.